Hello students, welcome to another session of this inverse trigonometric functions. This is Prakash Chogle, lecturer in mathematics. So in this session, we will be discussing expressing given inverse trigonometric function in its simplest form. So you will be given one inverse trigonometric functions and you are supposed to express it in its simplest form by using substitution or trigonometric identities. Okay, so let's begin. So in order to express any trigonometric inverse trigonometric function into its simplest form, you must know some of the identities. Okay, so let me write, you must know this 1 minus sine square x. Okay, so or 1 minus sine square theta. 1 minus sine square theta is cos square theta. Similarly, 1 minus cos square theta is sine square theta. Make note of this, sine square theta. Similarly, 1 plus tan square theta. 1 plus tan square theta is secant square theta. 1 plus cot square. 1 plus cot square theta is cosec square theta. Okay, and also note these two. Secant square theta minus 1 is tan square theta. Similarly, cosecant square theta minus 1 is cot square theta. So in order to express inverse trigonometric function into its simplest form, these are going to help. Okay, so take one example. So here is, write the function in the simplest form. So you are given one inverse trigonometric function, that is tan inverse of square root of 1 plus x square minus 1 by x. Okay, and you are asked to express it in its simplest form. So what we have to do is take suitable function and convert it into simplest form. Now one thing to be noted, whenever you find 1 plus x square form, okay, so within the inverse function, if you find 1 plus x square somewhere either under root or without root, so try to put express it in the form of 1 plus tan square or 1 plus cot square. Okay, so here 1 plus x square, I put x is equals to tan theta. Even cot theta can also be replaced. Okay, so put x is equals to tan theta. See here what it becomes. This implies if x is equal to tan theta, then theta is what? Theta you can write tan inverse x. Theta can be written as tan inverse x, that you all know. If x is equal to tan theta, then theta is tan inverse of x. So then what given becomes? Okay, so given is what? Your given is equals to, let me drag this. Okay, so this is your given. Okay, so this is your given and substitute here. Tan inverse of square root of, okay, 1 plus x square means tan square theta, and this minus 1 as it is, divided by x means tan theta. Okay, this is equals to tan inverse of, okay, square root of 1 plus tan square, I told you it is secant square theta. Minus 1 as it is, divided by tan theta. Okay. Now further, tan inverse of square root of secant square theta means it is just sec theta. Square root and square cancels. Minus 1 by it is tan theta. Okay. Which is equals to tan inverse of, okay, further I write this sec theta, I write 1 by cos theta. Minus 1 divided by tan theta, I write as sin theta by cos theta. Tan theta is written as sin theta by cos theta. Okay. So further go on simplifying. Tan inverse of, take LCM in the numerator, I can write 1 minus cos theta by cos theta into this sin theta by cos theta, right? Cos theta by sin theta into. I hope you agree. Okay. Now look here, cos cancels. So you will get tan inverse of 1 minus cos theta by sin theta. Okay. Now further you have to make use of two trigonometric identities. Okay. 1 minus cos means it is 2 sin square theta by 2. Better you note down that. And sin theta in terms of half angle, it is 2 sin theta by 2 cos theta by 2. Okay, better you note both the results, very important. 1 minus cos theta means 2 sin square theta by 2. And suppose if it comes 1 plus cos, that also to be noted. It is 2 cos square theta by 2. And sin theta in terms of half angles, it is 2 sin theta by 2 cos theta by 2. Okay, so please make note of this. Now after this, cancel whatever the terms get cancelled. 2 cancels and 1 sin term cancel. So you left with sin theta by 2 by cos theta by 2. Okay. So which is equals to tan inverse of sin by cos is tan. Okay. Now as you know, tan inverse of tan x is x, so I can write it as just theta by 2. Okay, because tan inverse of tan, this is known to you, tan inverse of tan x is x. So it is theta by 2. Now you replace your theta. What is your theta? Theta is, see your substitution. Theta is tan inverse x because you substituted x as tan theta. So replace theta as tan inverse x. So this is your tan inverse x. Okay. So this is your simplest form of given inverse trigonometric function. Okay, few more we will study. Here is the second one. Write the function in the simplest form. So you are supposed to express it in its simplest form. Okay. Now look here. In the denominator we have x square minus 1. Okay. So whenever x square minus 1, you have to bring in your mind sec square theta minus 1 or cosec square theta minus 1. Okay. You have to bring this in your mind whenever you find x square minus 1. If you find 1 minus x square, bring 1 minus sine square and 1 minus cos square in your mind. That is the hint. Okay. So you have to put one of these. Okay. So let us put, both are allowed. Put x is equals to sec theta. Okay. So this implies theta is equals to sec inverse of x. Okay. So therefore given becomes what? Therefore given is your tan inverse 1 divided by square root of sec square theta minus 1. Okay. Which is equals to tan inverse of secant square minus 1 is tan square. Okay. So secant square theta minus 1 is, as I mentioned, it's tan square. Okay. So now you have to write, this is tan inverse of 1 by tan theta. Okay. So because square root of tan square is tan theta. It is tan inverse of 1 by tan means cot theta. Okay. Now see here, you have to convert this cot in terms of tan. So this is tan inverse of cot can be written in terms of tan as, it's a tan of pi by 2 minus theta using allied angles. Because tan of 90 minus theta is cot theta. Now you can tan inverse of tan goes out. You can write it as a pi by 2 minus theta. Okay. So or pi by 2 minus and whatever your substitution, theta is sec inverse x. Okay. Look at this. You made substitution x as sec theta and theta is sec inverse x. Okay. And this can be kept as cosec inverse x. Why? Because there is a property, because sec inverse x plus cosec inverse x that we proved as pi by 2. So cosec inverse is pi by 2 minus sec inverse. This implies cosec inverse x is pi by 2 minus sec inverse x. Okay. So this is your simplest form. You can make method 2 also. You have to put this. Put x is equals to cosec theta. And theta is cosec inverse x. Okay, so you will get very simply, this much is not required. Inside here you will get 1 by cot. 1 by cot means tan. So tan inverse of tan, you will get directly theta and you will get this. Okay, so better you try this also. So let's have another example. Write the function in the simplest form. Cot inverse of 1 by square root of x square minus 1. Okay, so in the same way, just look at here you have square root of x square minus 1, So put x is equals to again sec theta. Okay, that means theta is equals to secant inverse x. Okay, why I have taken this means, look here, sec square minus 1 is tan square, under root tan square means tan, so 1 by tan means cot, cot inverse of cot goes, so you left with only simple quantity. Okay, so that is the reason. So before substitution you must know why you are substituting. Okay, so therefore given becomes, given is cot inverse of 1 by under root, this is secant square theta minus 1. Okay, so which is equals to cot inverse of 1 by under root, as earlier secant square theta minus 1 means it is tan square theta. Okay, so cot inverse of, it is square root of tan square means tan theta. So it is cot inverse of 1 by tan means cot theta, and as I mentioned cot inverse of cot is remove, so you can write it as theta, and whatever your theta you substitute. Theta is sec inverse x. See how you got the simplest form. Okay, so you must be good at the trigonometric identities. So let's have another example. Write the function in the simplest form, tan inverse of x by square root of x square minus x square. Okay, where mod of x is less than a. Okay, now see here, whenever you find a square minus x square, that is 1 minus x square form, try to make it in the form of sine square, that is 1 minus sine square. Okay, so you have a square here, so here there must be a square. Okay, so you put this, put x is equals to a sine theta. Okay, if you put x is equal to a sine theta, here you will get a square and a square gets common, otherwise you cannot convert. Similarly, if you have a square plus x square, then put x is equals to a tan theta. Okay, so this implies x by a is equals to sine theta. So what we will get? Theta is equals to tan inverse, sine inverse theta is equals to, you will get sine inverse x by a. Okay, so substitute here. So your given is, let me write your given, it is tan inverse of x divided by square root of a square minus x square you have. Okay, so substitute, this is tan inverse of x means a sine theta divided by square root of a square as it is minus x square means a square sine square theta. Okay, because x you have replaced as a sine theta and its square means a square sine square theta. Now look, this is tan inverse of a sine theta as it is. Okay, so what we will get? taking a square outside the root, you will get a. Okay, taking a common outside the root, you will get a, and you will left with 1 minus sine square inside the root. Okay, so now a cancels. This is equals to tan inverse of x. This is sine theta divided by square root of 1 minus sine square is cos square theta. Okay, 1 minus sine square means cos square theta. Tan inverse x into this sine theta by cos theta. Square root of cos square is cos theta. So which is equals to tan inverse of this is not x. So tan inverse of sine theta by square root of cos square theta. 1 minus sine square is cos square theta. This is tan inverse of sine theta by cos theta. Under root cos square means it is just cos theta. Okay, so now tan inverse of sine by cos means tan theta. Sine theta by cos theta is tan theta. So tan inverse of tan you can write theta. Okay, so tan inverse of tan theta is just theta, and whatever your theta you replace. Your theta is sine inverse of x by a. Okay, look at this. Your theta is sine inverse of x by a. So in this way you can express given in this simplest form. Let's have few more. Okay, so express in the simplest form, this is given. Okay, so no substitution is required, just use the trigonometric identities. Okay, so remember this. Note 1 minus sin x, okay, can be written as, actually 1 means it is sin square x by 2 plus cos square x by 2, and sin x can be written as, in terms of half angles, 2 sin x by 2 cos x by 2. Please note down this. 1 minus sin x can be written as, 1 means sin square x by 2 plus cos square x by 2, and sin x means in terms of half angles minus 2 sin x by 2 into cos x by 2. Okay. Now this is of the form a square plus b square minus 2ab. So I write it as cos x by 2 minus sin x by 2 whole square. Okay, so cos x by 2 minus sin x by 2 whole square. A square plus b square minus 2ab form is there. So I can write a minus b whole square. So remember that 1 minus sin x can be written as cos x by 2 minus sin x by 2 whole square. Even you can write sin x by 2 minus cos x by 2 whole square. Okay, but I prefer this here. Also, remember this. Cos x can be written as cos square x by 2 minus sin square x by 2. Okay, because cos 2x is cos square x minus sin square x. So here x means you have to write half of this x. So using these two identities, look, your given is what? Given is you have tan inverse of cos x by 1 minus sin x. We have this is tan inverse of, okay, cos x means cos square x by 2 minus sin square x by 2 divided by 1 minus cos x. Sin x means it is cos x by 2 minus sin x by 2 whole square, as I proved here. Okay, so now tan inverse of, in the numerator, see here, this is of the form a square minus b square. A square minus b square means a plus b, a minus b. So I can write it as cos of x by 2 plus sin x by 2, that is a plus b, into a minus b. So which is cos of x by 2 minus sin of x by 2 whole divided by this as it is, cos x by 2 minus sin x by 2 whole square. Okay, now see here, one of the factor get cancels. This cancels with one of the factor. These are two same terms. So whatever left you write. Tan inverse of, you are left with cos x by 2 plus sin x by 2 whole divided by cos x by 2 minus sin x by 2. Okay. Now you have to divide both numerator and denominator by cos. Okay, that is cos x by 2. So divide both numerator and denominator. Divide both numerator and denominator by cos x by 2. So what you will get? Tan inverse of, okay, cos by cos is 1, you will get. Sin by cos you will get tan whole divided by cos by cos is 1 minus sin by cos is tan. Okay, if you divide each term by cos, you will get this. Okay. Now see here, this can be written as tan inverse of, okay, so it is in the form of 1 plus tan x by 1 minus tan x, and which is nothing but tan of pi by 4 plus x by 2. Because you note down this, tan of pi by 4 plus theta is 1 plus tan theta by 1 minus tan theta. Remember this. Okay, so in the same fashion, this is 1 plus tan theta by 1 minus tan theta. So here theta is x by 2. So tan inverse of tan, you can write it as, they get vanish. So pi by 4 plus x by 2. So whatever your x by 2, your by 2 as it is, and you replace x, whatever you have taken. So no, we are not substituted anything in terms of x. So just this is the final result. Pi by 2 plus 1 by 2 x. Okay, so this is how you can simplify. So here is one more. Express in the simplest form tan inverse of square root of 1 minus cos x by 1 plus cos x. Okay, so you can make use of trigonometric identities. As I mentioned earlier, 1 minus cos means 2 sin square x by 2. And 1 plus cos means 2 cos square x by 2. I have mentioned earlier. Okay. So this is tan inverse of 2 cancels and under root sin square by cos square means tan square will get tan square x by 2. Okay, so this is tan inverse of square root of tan square means it is tan of x by 2, just square root cancels with square. So now tan inverse of tan x by 2 means tan inverse tan vanish, you left with x by 2. So this is its simplest form without substitution, just using trigonometric identities. Okay, so let's have one more. This express in the simplest form. Okay, so it is same thing that we done in the last problem. Divide it by both numerator and denominator by cos. Okay, so this is your given. Divide both numerator and denominator by cos x. Okay, why it is doing means you will come to know that this is tan inverse of cos by cos means 1 you will get. Okay, if you divide cos x by cos x, you will get 1, and sin x by cos x is tan x, cos x by cos x is 1, sin x by cos x is tan x you will get. Okay, so this is equals to tan inverse of, you may write it as I mentioned earlier, it is tan of pi by 4 minus theta, that is minus x. Okay, because note on this, tan of pi by 4 minus theta is 1 minus tan theta by 1 plus tan theta. Okay, so this is pi by 4 minus x. Okay, it can be done in another way also, using the properties of inverse trigonometric function, but I prefer this. Most of the students get confusing. Okay, so better you use this. Okay, so let's have another example. This one, express in the simplest form. Okay. Now you must know what is the value of sine or identity sine 3 theta. Okay, it's based on that. Okay. Put x is equals to a tan theta. Why? Because you will come to know now. Put x is equals to a tan theta. X by a is equal to tan theta. This implies theta is equals to tan inverse of x by a. Okay, so given is this. Let me write it. Okay, now what it reduces, let us check. This is your given. So substitute. Tan inverse as it is, 3a square as it is, and your x is a tan theta. So I write a tan theta minus x cube means a cube tan cube theta divided by a cube minus 3a into x square means a square tan square. Okay, because x is a tan theta. This much you have to substitute. This is tan inverse of. Now look what you will get. You will get 3a cube in the numerator. 3a cube tan theta minus a cube tan cube theta divided by a cube minus 3a cube tan square theta. Okay, so a cube is common in the numerator as well in the denominator. Okay, so a cube cancels. If you take a cube in the numerator and denominator, they get cancels. So every term is having a cube. So you left with 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Okay, now do you remember this 3 tan theta minus tan cube theta by 1 minus 3 tan square theta is, it is tan 3 theta that you have studied in first year. Okay, so tan 3 theta is this much. So which is equals to tan inverse tan. You left with 3 theta. Okay, tan inverse tan get vanish. So 3 into, okay, so theta is your tan inverse x by a. Okay, so this is how you can simplify given inverse trigonometric function. So you can expect one question from this also. So we will meet in the next session with few more examples.